Oh, yeah, that's what I did.
All right, for example 2, it says find the circumference if the radius is 12 centimeters. If the radius is 12 centimeters, that means that we're going to use 2 pi r because it's the one with the radius. Does everybody understand? So then we do 2 pi times 12. And can you multiply 2 times pi, or should you just do 2 times 12? Which gives you, and you get 24 pi. Look at us go. Well, fix it.
I got 75.
Yes.
If we did work out, is it wrong?
No. Yeah, you can work it out. That's fine.
So how come you can't do 3 times 1? Wow. How come you can't multiply it by 3.14?
Because that's not pi, that's an approximation of pi. I just said that.
Okay, well, I was trying to do that.
So you actually have to hit the pi.
Yes, you have to actually hit the pi button.
The calculator I had yesterday was acting a little wrong.
Maybe it's the operator.
No, I clicked times pi and it just gave me the number. It gave me like 2 pi. When I put 2 times pi, it gave me 2 pi.
Right, 2 times pi is 2 pi. So then you just hit S to D.
I'm saying when I typed it in.
Which one does it look like? Which of our calculators does it look like?
Not this one. Not this one.
Yeah, it looks like the one that we usually use. It was this one.
Okay. Thank you. So you would do 2 pi, oh, I didn't hit the 2. 2 pi, enter, and it gives you 2 pi. So then you can hit, oh, Blair. Why? Ooh, I don't like this one. Okay, well, that's fine. I'm not going to count off unless I say round to the nearest tenth. And then we'll have to figure this one out and figure out how we're going to get it to convert. We'll have to ask somebody that uses this one all the time. All right, example 3. It said find the radius if the circumference is 36 pi. This time you had to find the parts. It asked for the radius. So which formula are you going to use? 2 pi r. And that's where I got that from. Then I plugged in 36 pi equals 2 pi r. And what did I divide by? 2 pi, because I'm looking for r. Fantastic. Make sure you have these written down. If you don't, what should you be doing? Magic. How many of us watched the videos last night where I did this page and the next one for you? Great job, Caitlin. Take a point just for you. The rest of you, you're dead to me.
Okay. All right.
Why are you the way you are? We did kick him off the island. But why? We kicked him off the island for so many reasons. Like, how many chances do we give?
I think killer.
He murdered him.
Right. Like, what else do you want us to do to try and save this man?
We're recording too.
So now
Yeah.
you're a dog.
All right. So Curtis is still off the island. Example 4. Now this circle is inside the square, right? And do you see how the edges of the circle touch the edges of the square? If the side of the square is 10 millimeters, what would the diameter of the circle be? 10 millimeters. And you would use pi d. How many of us did this part right without watching the videos last night? 2 people. Oh, that's a better. Good. Take a point for this side of the room. The rest of you?
You're still there.
All right, open to the inside. All right, example 5. It gives us a right triangle inside the circle. And does it give us the diameter? I don't know why we're saying it is a question and only one person is attempting to answer. This is a diameter. Do we know the length of that? What are these 2 segments called? We learned it yesterday. Towards, thank you. What kind of triangle does this make?
Right side.
And how do we find the missing side of a right triangle? Dun 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 dun. Write that down.
Oh yeah, let's go.
That's a lot of shapes to look
Hmm.
at. That's a lot of shapes to look at.
A lot of shapes to look at. Boy, it's two.
And you have the chords.
Oh yeah, true. I see. You just saying
You're disagreeing with him and disagree with me. Alright, so then I'm looking for the hypotenuse, right? And that's my diameter. So I have 16 squared plus 30 squared equals d squared. I called this d because it's the diameter.
I always look at doing circles, right? I end up doing triangles up there.
Well, bruh, they all relate to each other.
I need them to like, I don't know, somebody needs to get divorced or something.
Might need to get this stuff together.
They are. They're together in the circle. See what I did there? Alright, then we do 16 squared. What is 16 squared? And what's 30 squared?
900.
Fantastic. What are we going to do with those two numbers?
I don't know.
Alright, how do we get rid of the squared? And what's the square root of 1156? 34. And then since we have the diameter, which formula are we going to use? Pi d. So it's just 34 pi units. I know. The next one is going to be even better. Like a unicorn.
Oh, sorry, she said something that was funny. Don't judge me, Miss Aspen. I swear, you always look at me like that. Like, come on,
Man,
man.
PUBG basically.
Alright. Let's look at this one. Now, you have 8 and 8. Pretend you don't see that. What do the tickies mean? They're congruent. Alright? So if this side's 8, that means this side has to be 8. Now, this is a right triangle, and it's also a square. When we cut a square in half, what special right triangle do we make? 45, 45, 90. And if our side lengths are 8, what does that mean our hypotenuse is?
8 root 2.
8 root 2. Okay? You could also use the Pythagorean theorem, which I show you here, but you don't have to do that. You don't have to do that. And it gives you the diameter. So what formula are we going to use? Which is 8 root 2 pi units. Magic. I don't know what words you just said.
How do you know if you have to use that or not?
If you have a special right, you don't. But this one wasn't a special right, so you do.
Well, it's another special rate.
It's a square.
But like, what if it wasn't a square? Like, it just shows triangle. Like, it just shows triangle.
And it didn't give you any angle measures, then you'd use Pythagorean theorem. Yeah. So if it wasn't a square, if it just looked like this, Pythagorean theorem. Now, let's look at example 7. It's 2.
3, actually. There's a triangle inside of a triangle inside of a circle.
And there's a little square.
I'm about to say things.
Okay, now, these tickies mean that all the sides are what? Okay? And if all the sides of a triangle are congruent, what do we know about the angles? They're all 60. Good, take a point. So that means that this is 60, and this is 60. And what do you think that this radius is going to do to that angle? It's going to cut it in half. Who said that? Take a point. So half of 60 is 30. So do we have a special right triangle now? We do. What kind? And our pattern for 30, 60, 90 is... You have notebooks you can flip to. Doo-da, doo-da. Yes, take a point. X. X root 3 and 2x. What side length do we have? Do we have the 30? Do we have the 60? Do we have the 90? We have the 30. So that means I'm going to write 6 right here. And our hypotenuse is the 90. We do not care about the 60. We don't need that. It doesn't matter to us at the moment. All we need is our radius, which is this beautiful piece right here. Does everybody agree? How would we find that?
6.
6 times 2. Take a point. And what is 6 times 2? 12. Yes. I'm sorry? The 90-degree angle? Thank you. I was just confused on what you were asking me. But now I'm better. Are you also better? Go team. Okay. So, Justin, if we know that this is 12, are we going to, which circumference formula are we going to use?
Circumference.
Yeah, because that's what why are you saying circumference like you've never heard that word before?
Oh.
Which, we are going to use 2 pi r. And why are we going to use 2 pi r? Thank you. Take a point. And what is 2 pi times 12? 24 pi. Are you tripping? Because we don't need it. It's our 60, right? So this is our 60-degree angle right here, this pink dot. And that means that this is our 60. Is that a radius or just a chord? Or part of a chord? It's part of a chord, and you don't need that. Yep. That's a good question. No. All right. Example 8. If this is 30, what is this top angle? And what is the pattern of a 30, 60, 90? Thank you, zombies. All right. What part did they give us? Did they give us the 30, the 60, or the 90?
30.
Okay. Well, 30 would be this one. So did they give us that chord? No. And 90 would be the hypotenuse. They gave us the 60. So I'm going to write 9 root 3. Now, we need to figure out what x is. What is x? Why is x 9?
60 is 9 root 3, it's x root 3, so you take away root 3.
Take a point. You take away root 3, it's just x, so you get 9. But we need our hypotenuse. It's 18, because you would just multiply times 2. Also, Deontay, I heard you say that a minute ago, so go ahead and take a point. And what would the circumference be? Would we use pi d or 2 pi r? So what would it be? 18 pi. Look at us go. Are you ready to practice super fast? Alright, I'm going to pass these out super fast. We're only doing part. The rest is homework. Then we're moving on to our lesson for today.
Isn't the chord DE?
OD.
A chord could be DE. Alright, name a radius.
CP.
CP. Name a diameter.
AB.
Name a radius not drawn as part of the diameter. Well, we already did that. Which one is that? CP. Suppose the diameter is 16 centimeters. What would the radius be? Yep. All right, do number 7. Oh, we are killing it today, children. Hello. Thank you. Grab one from each stack at the front. And here's the worksheet that we're working on. Not that one. All right, what did we get for AB? 22 inches. Look at us go. Eh.
So diameter is bisected. She's trying to take like 4 points.
Well, this is 11, right? And that's a radius. So if that's 11, what's this one? What's AP? And what's PB? And then, yeah, add them together. So, yes, diameters bisect each other, but the radius also bisects it, and it depends on what part of your circle it's all connected to. Could we use any of this information to find DE?
I was just about to ask that
Well, do we have enough information to find that?
No.
Does it create a triangle that we could use our
Hold
step
on.
one?
Oh, wait a minute.
DPE.
Wait, no, that's all.
Well, could we?
I bet CD.
All right. So Justin was saying if we connect this and this, right? We know that BP is 11 and PE is 11, but is that still enough information to find that?
Yes. DPE, because I could do.
Is it a right triangle?
No, that's
We don't necessarily know that, do we? Okay. We're going to come to that soon, children, but not today. All right, the diameters of F and G are 5 and 6 units. Find each measure. So BF, how do you think we could find that? Take a mo and look at the circles.
I bet.
This is true.
Where?
Yeah, you get. It's hard to tell.
Yeah.
It's hard to tell.
Yeah.
So F is the.
F is the circle on the left.
AF is the radius of the first circle.
Yes. AF is the radius of the first circle, and what would the length of AF be? Let's just list the things we know.
Would it be 5?
Well, the diameter of circle F is 5. So what's AF? 2.5. Okay. This is our first circle. Does it help? Awesome. And this is our second circle. Would it be FG or would it be BG? Okay. BG would be 3. Okay. Now, do we also know FG? What would FG be? If AF, and remember, this is still part, pretend like the blue circle's not there. AF is 2.5, and FG is also a radius, so what would FG be? Okay. Now, could we subtract FG from BG and get that little part?
Yeah.
All right, do that. All right, now I want you to use that and find AD. Remember, you know what AF is.
Oh, this is easy. I don't know.
It just takes a minute once you have to look at it.
I'm not going to sit there.
Circles are super fun.
Oh, I'm tripping.
Are you?
Yes.
Maybe sit down.
I'm going to.
Sliding off the edge of a cliff.
My D.
All right, what did we get for AB? 2.
2.
Oh my gosh, I'm so proud of y'all. Take a point, children. Just one. Don't go crazy.
All right. Just, I was ready to party, man.
I'll be telling myself to take a point. You should take a point like that.
So many things. So many things I can't say. All right, so this one it says find the diameter and radius of a circle with a given circumference. Set that equal to 2 pi r. What are we going to divide that by? 2 pi. So in your handy dandy calculators, do 36 divided by 2 pi. Put 2 pi in parentheses.
That's 18 pounds.
It's 18 divided by pi. Because you divide it by 2 pi.
So it'd be
Oh, 5.7.
18 divided by pi.
You need a calculator.
It'll be 5.7.
All right. Because it says, well, round to the nearest hundredth. So 2 decimal places. 5.73. All right. Now take that and find the diameter.
Keep on that pi.
All right. So you take 36, right? And we're going to divide both sides by 2 pi. So in your calculator, you type in
36 divided by pi.
36 divided by 2 pi.
At 56.
Yeah. That's what I got.
Okay. Hold on.
You said put in parentheses.
I did. Hold on. Oh my gosh. Do what I asked you to. All right. Do number 11.
I get 5.73.
It says round.
Oh, yeah. All right.
I don't even know how to deal with you. You slow your roll.
I am going pretty slow right now.
Retweet.
Follow me on Twitter at Justin.
You're doing this math problem?
Yeah, that's my Twitter.
Super fast. And then we're going to look at 14. And I'm super excited. No, we're not. You're doing those for homework. I got excited.
I hope I did this right.
All right, what did you get when you divided it by pi? 2 pi. What?
I had 12 points.
1.29.
12.
And then we multiply it. And then you get
And then you multiply by 2 to get the diameter.
5.48.
What did we get for? I just forgot the number because we're all shouting stuff at me.
2.74.
And then the diameter.
5.47.
Thank you. And it should be in feet, correct? Look at us go. All right, 12, 13, 14, and 15 are homework. Are you ready for the foldables for today? Well, get ready, Tater. You have 2. The first one, put it on your desk like this. Are you not entertained? Then fold it in. And what are you going to do on those? These right here.
You gotta cut them.
No, guys. I'm just folding. I'm just folding in so it makes a little booklet. We've done these before.
Make flappies.
And then you make flappies. We are getting fancy. Just wait till the one, we're doing a really fun one next week.
Is it actually fun?
Yes?
What's your definition?
Foldables.
That's my definition of.
What's your definition?
Justin, check yourself before you wreck yourself, son.
I said that a lot.
Let me just go ahead and throw that out there at you.
I don't want to take anything to eat right now.
I think it's so
And I'm not cold.
Cameron, what do you need to tell me?
I said I love you.
That is not what you said.
You said your definition was fun.
Bro, stop looking at me.
Paper cut. We're getting a little too hardcore in here, kids. Calm down.
I apologize. I'm sorry for this.
One roll to the
You got.
Made the wrong turn in life.
Y'all have been around me a little too long now.
And that-
I went to the ER for
that's why.
Christ, you probably did.
I did. I was playing football and I thought I was really bad, but then when I went down, he was in spray.
Okay.
I don't remember the last time I went to the gym.
All right. This is on page 66A.
Why not photo put like on
Mine does too. I don't know. The copier has not been my friend lately, especially on my foldables. All right, so we have 2 learning targets for this section. The first one says, I can identify arcs of a circle
We're getting a little wild. Hold on.
and find their measure. How about I write both of our learning targets down and then I'll pause?
Okay. Cameron's getting wild. Is anyone in the picture?
Yes. That's what your second foldable is going on. Alright, so 66A is this foldable. 66B is the one that says arc length, a little half foldable. I will give you a mo. Alright, so the first part, which hopefully we'll get through today. I can identify arcs of a circle and find their measure. Now we know that the arc is the outside edge of a circle because it looks like an arc. Does everybody understand? I am super sorry. Start with central angle. Now what do you think the words central angle mean? Okay. An angle at the center. That's actually pretty close. Alright, so an angle, I'm super proud. What is the point of an angle called? Starts with a V. Vertex. Alright?
He said vertices, so I didn't say anything.
An angle with its vertex. I know. Persevere in the face of danger. At the. Just tell me to move it over.
There you go. That's what I was trying to do.
Okay. An angle with its vertex at the center. Of the circle. Now it also does super fun to arcs. It separates the circle into two different arcs. So separates circle into two arcs. Now we're going to look at our circle. How would we name a central angle? Well, there's several angle C's, aren't there? There's one right here, there's one right here, there's one right here, there's one right here. So, ACE, take a point. You go from the outside to the inside to the outside. And why do we have to use C? Because it's the center, okay? So we would write angle ACE. Is there another one? You're fine. EC what? F.
What? You put B, even if there's not a line under it?
It doesn't connect to one, does it?
You just kind of chill.
We're going to talk about B in a minute. It will come into play, but not now. What's another one? FC. We did that one. FCD. And there's one more.
ADA.
A-
I mean ABC.
FCA.
I said ADA.
ACD. We're not judging you. We're just very confused on what angle you were trying to name.
I have a question.
Yes.
Does it matter from where you start? Like, do you have to start from the top and go that way, or can you just like?
So I can pick any point on the edge of the circle, right? So I could start at F, but then I have to go to the center, and then I could go anywhere.
If I roll FCD,
It could be ECD, but that's a line. So what would the measure of that be? 180. And also, what does that one cut the circle into? A semicircle. And so what would the measure of a semicircle be? Let's leave this to our next floppy. Yes.
I'm about to sound like go ahead.
Forgot one.
Where?
ECB.
We just
ACF.
We can't connect to B. And why can we not connect to B here? Is there a radius that goes here? Fantastic. FCA? Okay. Would that make a semicircle, or does that look like it's kind of more obtuse? Okay. Good job, guys. All right, let's look at semicircles, because what Devin and I just talked about leads us to our next flappy. So what do you think a semicircle is?
Half of it.
Okay, so it's an arc with a measure of what? 180. So let's write that down. It is an arc with what, darling? Oh. Stop. Oh my.
You know about the afro? That was so funny.
Okay. Now for a semicircle, you have to use 3 points. You use the end points of half the circle and a point in the middle. So it is named with 3 points, 2 end points, and 1 in the middle. Bless your soul.
Thank you, man. Thank you. Why are you?
All right, so how many semicircles do we have here?
2.
We have 2 because it can only be cut into how many halves? Fantastic. Okay, name one for me.
ACD.
AC. No, we have to go to the outside.
Oh, I'm tripping.
ACD?
EAD.
Okay, stop.
Whoa.
Breathe. We need 3 points. We need end points, right? So cover this up. That makes a semicircle. You have to go to the outside. So it's the end points and 1 in the middle. So I would go EAD. It's in the middle of those 2 points.
But there's no line.
No, not actually in the middle. It's just in between the 2 points.
There's no line.
Right, baby, but an arc is the outside. So an arc is all of that.
Oh.
Thank you. What what would the other one be? EFD? So EFD or EBD, you can name it either way, right? But they make the same thing. And you do have to put a cool little arc on top. What, darling?
We can use B.
You could use B now because it's on the edge, right? So
FB.
FB what?
FB.
Is that half the circle? So EAD, EBD, or EFB. EFD, I'm sorry. All right, we're ready to look at minor arcs. Now, if a semicircle is half of the circle, what would a minor arc be?
Maybe a quarter of a.
Or anything less than what? Anything less than 180. All right, so a minor arc is anything less than 180 degrees. What color do I want to use this time?
Blue.
Purple.
Green.
Red. She's going to use green.
Yes?
What are you gonna do with this?
We don't know.
How you not going to be able to see?
Because my eyes so strong.
Okay. All right, an arc with a measure less than 180. Named by endpoints. So for a minor arc, you only use 2. So look at your circle. AE is 1. I'm going to zoom out some. EB is 1. All right, so we have AE, we have EB. That's supposed to be an arc, not a line. AD. Now, the reason I question AD is because we said that the semicircle was EFD, right? And A goes beyond that. Oh, you're talking about this way. Okay, sorry. I got confused. Is it important with how you look at the circle?
Yeah.
Fantastic.
Counterclockwise.
DF. All right. What about BF? We could use that because it's the edge, right? So we don't care about what's on the inside. We care about the edge right here. Are there more minor arcs than major arcs in this circle? Yes. How many letters did we need to label that? Write that down. 2 letters. So if a minor arc is less than 180, a semicircle is 180, what would a major arc be? More than 180. So a major arc is, whoa, is an arc with a measure
Unlike any test we take for papers, are we going to have to specify if we're going clockwise or counterclockwise?
No. If you use 2 points, I'm going to assume that it's a minor. If you use 3, it's a major. All right, so you have to use 3 points for this. 3 letters for this one. 3 letters. All right, so let's find a major one. EFA. Yes, EFA. Follow the direction of the points. EFA. What's another one? FDB could be one. All right, somebody besides Grant find one. BFE. Okay.
ABD.
Hang on. BFD. I heard ADF. I heard some kind of something something.
ABD.
ABD. Yep.
Now, when we use the arc, can we use B? Like if I said F? Oh, never mind.
You can, because it's on the outside. So the only reason we couldn't use arc for, B for a central angle is because it doesn't have a radius that connects those. So you're going to use the outside. All right, now your other homework for tonight is the inside. It gives you part of these, right? Tells you that this arc is 60. And a fun fact about this, if the arc is 60, what do you think the angle is going to be? 60. That's the first one. Does anybody have any questions? So you need to finish the inside of this and 11, 12 through 15 on here. 2 homework assignments tonight. Yes, sir.
What's on the other side after
All right, so it says to find the measure, and then next to each measure, write the name of the arc or angle. So what would FCD be? Would that be a central angle, a semicircle, a minor arc, or a major arc? It's an angle, right? So it would be central angle. Yes. Yes. What would AE be? What would the measure of AE be? 45. And what kind of arc would it be? Minor arc. Take a point. All right, tomorrow we are doing arc length and you're going to have a quiz. Get super excited.
Tomorrow?